Deep in the foothills of the Himalayas, near Rayasi, exists a landscape where no human structure was ever meant to stand. Here, the environment is defined by extremes. Temperatures swing violently, dropping from a scorching 50 degrees Celsius down to freezing. Jagged cliff faces carve out deep, dangerous canyons, and the geology is treacherous. Yet, spanning one of these formidable gorges is a feat of engineering that defies the odds: the Chenab Bridge. Maneuvering the 30,000 tons of steel necessary to build it required overcoming logistical nightmares in one of Mother Nature's most unforgiving environments. The construction of the Chenab Bridge was necessitated by a critical need for connectivity. The Kashmir Valley, separated from the rest of India by imposing mountains, has historically relied on National Highway 44. However, this arterial road is frequently blocked by snow, severing vital links. The bridge is the centerpiece of a new 169-mile all-weather railway line designed to cut through the mountains, comprising 943 bridges and 36 tunnels. This massive infrastructure project aims to boost the local economy and ensure reliable travel between Jammu and Kashmir, regardless of the season. Simply reaching the construction site was an undertaking of immense proportions. Initially, there were no motorways, no nearby factories, and no stable ground. Engineers and surveyors first accessed the site on foot or by boat, navigating the river to bypass tortuous mountain paths. To facilitate the movement of heavy machinery and materials, crews had to construct 26 kilometers of roads. These access routes were engineering challenges in themselves, clinging to the sides of mountains and skirting precipitous cliff edges. Logistics dictated a unique approach to materials. With no way to transport massive, pre-assembled components, the steel arrived as flat plates, akin to flat-packed furniture. All cutting, drilling, and fabrication had to occur on-site, in purpose-built workshops perched on the canyon rim. Once the materials were ready, the teams faced the daunting task of assembly over a gorge where winds can reach 165 miles per hour. This phenomenon, known as the Venturi effect, occurs when the narrow canyon funnels wind, increasing its speed and dropping its pressure, creating chaotic, powerful gusts. The geological instability of the Himalayas added another layer of complexity. As a young mountain range formed by the collision of the Indian and Eurasian plates, the landscape is twisted, and the rock is often fractured. A standard bridge design, with vertical towers, was deemed impossible. The unstable slopes meant towers would likely slide down into the valley. Consequently, engineers opted for an arch design. By anchoring the structure into the mountainsides, the two halves of the arch could meet in the middle, locking together and driving the force down into the bedrock, ensuring stability against both gravity and the region's frequent seismic activity. Constructing this arch hundreds of meters in the air required a massive cable crane, functioning like an industrial aerial trapeze. Towers erected on either side of the canyon supported cables that winched steel segments into place. The arch was built in sections from the bottom up, held back by cables anchored into the rock to prevent them from plummeting into the river below. Only once the arch was complete and locked could the support towers and top deck be installed. Using a launch methodology, the bridge deck was pushed out in sections from both sides until it met in the center. The engineering marvel extends to the finest details, particularly regarding temperature control. The extreme thermal variance causes the massive steel structure to expand and contract. If the railway tracks were fixed rigidly to the bridge, this movement would warp the rails, making train travel dangerous. To solve this, the rails are pre-stressed and seated in fixings that allow them to move freely. As the bridge creates friction and moves with the temperature, the tracks slide back and forth, remaining safe for transit. After more than 2 decades of labor, traversing delays, geological surprises, and logistical hurdles, the Chenab Bridge now stands complete. It is a testament to human determination, rising from a place where crews once relied on donkeys and boats. The structure not only links a divided region, but also redefines what is possible in construction. By battling wind, snow, heat, and seismic volatility, the engineers behind the Chenab Bridge have carved a path through the clouds, proving that with innovation and resilience, even the most impassable obstacles can be bridged. Stay with us and subscribe button and switch on notifications. The frontier of the future is unfolding, and you'll want a front row seat.